Let's dive right into this explainer and uncover the gritty, heavily engineered reality behind an ingredient literally almost all of us use every single day. We're talking about sugar, right? But I want you to forget about those pristine white crystals sitting in your pantry for just a second. We're going to step inside a massive, roaring industrial factory to see exactly how this realistic sugar production process actually happens. And it is on a totally mind-blowing scale. Just to kind of wrap our heads around the sheer size of this operation, think about this. The average person in Ethiopia consumes about 32 kilograms of sugar in a single year. Now multiply that by the entire global population. That is a staggering amount of demand. And meeting that demand, well, it requires an incredible industrial response that literally never sleeps, just constantly churning through mountains of raw material.
So it really makes you wonder, right? How exactly do we extract absolute molecular perfection from a 5-meter-tall woody plant? Well, spoiler alert, it is far from a gentle process. It takes brutal mechanical force, extreme heat, and some really precise chemistry. Step by step, we're going to see how sugarcane goes from the dirt all the way to your table.
Okay, so here's our factory floor map for today. We'll start with harvesting the green fields, move on to crushing and extracting the juice, tackle the boiling and evaporating process, check out the crystallization and centrifuges, and finally, wrap things up with sweet waste and renewable energy. Let's get into it.
Section 1. Harvesting the green fields. We're starting our journey wide and organic, out where the raw material is born under the hot sun.
You know, there's this stark, almost jarring contrast between sugarcane's agricultural origins and its final industrial destination. Out in the quiet, green fields, you've got agricultural workers and massive combines harvesting the cane. But the absolute second those trucks transport the stalks to the factory, it hits a wall of roaring, heavy industrial machinery just waiting to tear it apart.
We are bridging a massive gap here. We're going from organic, earthy plant matter to a highly complex, precise chemical compound known as sucrose. And really, this entire heavy-duty industrial journey is dedicated to one single obsessive goal: isolating that exact molecule and aggressively stripping away absolutely everything else. Section 2. Crushing and extracting juice. Let's leave those quiet fields behind and enter the loud, brutal mechanical phase where the real extraction begins. So, once that cane is cut, a ticking clock immediately starts. It has to undergo this intense mechanical prep within 24 hours of harvest, or else that precious sugar content starts degrading. First up, a heavy wash blasts away the mud. Then, rotating knives and shredders violently tear open the plant cells before it's fed into aggressive crushing machines to squeeze out the juice. Interestingly, engineers actually have two totally distinct ways to get that sweet juice out of the shredded plant. They can either physically crush it using massive iron rollers while spraying water to wash the sugar out, that's milling, or they use something called diffusion, which relies on hot water and chemical osmosis to just naturally draw the sucrose out at a cellular level. But either way, what we're left with is a very murky raw liquid. Section 3. Boiling and evaporating juice. Having squeezed out that murky, acidic liquid, we're smoothly shifting from brute force into precise, scientific chemistry. Right now, that raw juice is highly acidic and just packed with dirt and fiber. To clean it up, workers kick off a really brilliant chemical sequence. They preheat the juice, add something called milk of lime to tweak the pH, and then bubble sulfur dioxide gas right through it. This forces all the suspended dirt and impurities to clump together into a heavy, dark sludge. It settles to the bottom of these massive clarifier tanks, leaving behind this beautifully clear juice at the top. But that clarified juice still contains way too much water, so it gets pumped through massive evaporators. And here's the clever part. They use vacuum pressure to significantly lower the boiling point of the liquid. Why? Well, if you try to boil sugar water at normal atmospheric pressure, you're just going to burn the sucrose, and nobody wants that. The vacuum lets them safely boil off the water, turning that thin juice into a super thick, concentrated syrup. Section 4. Crystallization and spinning centrifuges. We are now entering the final high-speed magic of the factory, where our liquid syrup finally becomes solid. Inside these massive vacuum boiling pans, that thick syrup gets evaporated even further. To actually force the sugar crystals to form, workers introduce a tiny seed grain into the mix. As the crystals latch onto that seed and grow, it creates this wonderfully industrial, dense, sticky mess called massaquit. Basically, it's a heavy slurry of solid sugar crystals
trapped in a dark, liquid mother liquor, which you and I know as molasses. All right, so we have this sticky mass, but we need pure crystals. How do we separate them? The massacute is dumped into revolving centrifuges. Picture giant industrial spinning baskets. These things spin at an insane 1,800 to 2,400 RPM. That immense centrifugal force literally flings the dark, liquid molasses right out through the perforated walls of the basket, safely trapping the pure, light brown raw sugar crystals inside. It's awesome.
Section 5. Sweet Waste and Renewable Energy. The sugar is basically dried and ready for packing now, but the story doesn't end there. A modern sugar mill is essentially a self-sustaining ecosystem.
It is genuinely fascinating that absolutely nothing goes to waste in these factories. Remember those leftover crushed stalks from the very beginning of the process? They're called bagasse. Well, they are burned in high-pressure cogeneration boilers. These boilers are so incredibly efficient that they generate enough steam and electricity to run the entire factory. They often even export surplus power back to the local grid. Meanwhile, that dark press mud from the clarifiers, it goes right back out to the fields as agricultural fertilizer.
And get this, even the thick, dark molasses that was violently flung from the centrifuges has massive industrial value. Roughly 70% of it is shipped off to distilleries and fermented to produce ethyl alcohol, or ethanol, which is a huge component for biofuel blending. The remaining 30%? It gets utilized as carbohydrate-rich cattle feed or processed into citric acid. Every single byproduct has a purpose.
So, that brings us to a final thought for today's explainer. The very next time you casually stir a spoonful of sugar into your morning coffee, I want you to ask yourself how much heavy machinery, intense boiling, complex chemistry, and high-speed spinning went into isolating that one perfect crystal. I hope this deep dive leaves you with a profound appreciation for the massive, hidden engineering journey required to sweeten our daily lives. Keep observing, keep questioning, and we'll see you in the next one.